All right, guys. Deal is today is 1.02 complex numbers, adding and subtracting. So we're going to talk about this. Obviously, we've had some issues with Teams and technology, so hopefully you can use these as a resource. Complex number is in the form of, it's either going to be A plus BI, or it can be A minus BI. All right, it could be either one or the other. Sometimes we'll just simply write it as A plus or minus BI, but it will never be plus or minus. It's either going to be plus, minus. It won't be both. Okay? A is the real part, and B is the imaginary part of the number. All right? They're separate. So while they're both numbers, so we have real numbers and we have imaginary numbers. They're both numbers. You cannot combine them. All right, it's key that you understand that. You can't put them together. So when we're looking at adding like terms, or what is a like term? Like terms are when they're the same type of stuff. So a like term, if you want to add, would be 2 plus 2. Well, you can add that, which is 4. All right? Or 3i plus 3i, which would be 6i. Okay? What about if we had like terms, or would this be a like term? What if I had, let me think for a second, 2 plus 3i. Well, obviously that's our complex number, but 2 and 3i are not like terms, so you cannot combine. All right? You cannot combine them. So what about other things? I want to erase this. Hopefully you have it or see it or sit or whatever. This way, this is a good thing that I can erase now. What are some other examples of like terms? So what if I had, let's say 2 plus the square root of 2. Can I combine those? Well, no, you can't, because 2 is a real number, and square root of 2 is a real number, but they're not like terms, so you cannot combine. What about if I had square root of 2 plus the square root of 2? Could I combine those numbers? Let's get a calculator and let's just see what would happen if we did that. We put this into a calculator. Square root of 2 plus the square root of 2. I don't know if you can see that. Let me see if you can see that. Yeah, maybe. So you can combine those, and this would end up being 2 square roots of 2. Okay? You can technically combine those. All right? What about other situations? There could be multiple where it is, what if I had I square root of 3 plus I square root of 3? Well, those are the same things. This is one of them, this is 2 of them, so you could technically have 2i square roots of 3. That is combinable. What if I had I square roots of 2 plus I square roots of 3? Well, the I is the same, but the roots are not the same, so you cannot combine. Okay? So we're dealing with this. They're going to be talking about the adding and subtracting of complex numbers. So what if I had adding complex numbers? What if I had 2i plus 6i? Well, while you couldn't combine these over here because these two didn't match, and the reason for that is you can't combine radicals. I always think of radicals or things that are underneath the radical, like a variable. For instance, say I have 2 and 2, that'd be like x and x. Then you'd have 2x. But what if I had x and y? I can't combine x plus y, so it's just x plus y. I can't put them together. A little bit different on this scenario, okay? These do not have to be the same. These are simply numbers. So this can be considered 8i, okay? Little bit different here, little bit different here. So let me erase a little bit of this. You can always go back. That's the beauty of video. You can always go back and rewind it. So if you think of it in these terms, if I have I radical 2 plus I radical 6, this is very similar that if I had I times x plus I times y. You can't combine that, okay? You cannot combine that. However, if you had like this number, this is totally different. This is where the number is out front. So never would we write like these are in the back. These are like the radicals. We would never put our y or x out front. X times I plus y times I. It would never be written like that. It would not. So you can always combine this. I hope I didn't go too deep into this, too explanatory, but over-explanatory. But anyway, now what if I had 3i root 2 plus I root 2? First and foremost, the question that has to match are the i's, and do the roots match? It does not matter. We just confirmed that this doesn't matter, the number in front of the I. That's what you're actually combining. The number in front of this I is technically a 1. So this you could combine, and this would be 4i root 2. And you could combine that. This is where things can get a little difficult at times trying to understand these things. Probably won't go to this depth of difficulty, however, it's possible if we do. Subtracting, the only thing you need to recognize is the actual operation. This is adding. So what if I had 3i root 2 minus I root 2? Well, that would just simply be 3 minus 1, which would be 2i root 2. This portion doesn't change, if you haven't noticed. This portion doesn't change. The portion back here doesn't change. What does change is that number out front. If there isn't a number out front and these two can't be combined, then obviously this can't be combined, okay? What's changing is the number out front. Hopefully we recognize that. All right, let's erase. Let's bump up the board and let's keep her moving. Wow, I went a little quick there. All right. It says simplify, put answer in standard form. Standard form is obviously A plus or minus BI. All right? So, first things first, I always want to get rid of these parentheses. If there's a plus in the middle, all it is these things just simply come down. What are like terms? What matches? Well, we have 8 plus 21. What's 8 plus 21? 29. Then we have negative 1i plus 16i. Comes down. And that is your final answer. The next one, number 2, a little bit more of a challenge. Why is it a little bit more of a challenge? Well, because we got to deal with that negative. So this negative, understanding this is crucial. We have to distribute that to that entire second parentheses. The first set can simply just come down. That just comes down. There's nothing in front of it to distribute. So it just comes down. Once we distribute this negative to negative 5, it becomes 5 positive. Negative 1 times negative 5 is 5. Negative, because there's like a 1 here, is minus 7i. Now we have to determine our like terms. First set, 3 plus 5 is 8. Negative 3i, negative 7. Ah, this pen's not working for me. Oh, gotta go bye-bye. Negative 10i. And that's your final answer. It was 8 minus 10i. You cannot combine them. One's imaginary, one is real. This next one, we have multiple parts. Obviously, we have the 7i that simply comes down. Then we have the distribution of the negative, or negative 1 to each one, which would make that positive 2, positive I. And then we simply have positive 3i. Multiple parts here. Separating them all is crucial. I, positive, positive, leads me to 7 plus 1 plus 3 is 11. I, and then we have the 2, positive, and done. Again, cannot put the 11i out front. Imaginary parts in the back. All right, next one. 10 comes down. Negative gets distributed. 7i comes down. And there's our next little set we have to combine. 10 minus 6 is 4. Negative 2 plus 7 is positive 5i. This is not that difficult. When we start multiplying and dividing them, it will become much more difficult. Again, just trying to get you guys warmed up, and hopefully the Teams is working well. Obviously today it didn't work that well on a couple classes, but hey, we are what we are. So we're going to do 2 more, and then that'll be it for the video. All right. Now we have multiple pieces, 3 pieces. This is positive here, so all you have to do is bring it down. And I like to rewrite all of these. I just do. I think to be consistent, it's important. Since that's a positive out front, everything just stays the same from the inside. This one, however, has to be distributed. That negative 2 times negative 2 is positive 2. Negative times positive 2i is negative 2i. From there, we have to find like terms. Do your real numbers first. It helps. And putting boxes around everything helps as well. I promise you it does. I don't do it just for you. I do it for myself included. 5, 8, 2 is 15. I and I simply cancel. Negative 2i. I would not try to do all of that in one step. You don't have to do every little detail up here that I did, but it will help you to be consistent with what you're working for. Okay? Last one, again, positive out front, so this simply just comes down. Positive out front, so this simply just comes down. Negative that gets to be distributed and written out accordingly. Well, if we look at this, 8, -8, -5, well, 8 minus 8 cancel each other, so you have -5. I have -I, positive 5i, -i. That's like saying -1 plus 5 minus 1. So I got -2 plus 5 is positive 3i. And it is okay to have a negative out front. Not a problem with that. So the goal for today is to finish this, and then you will do, I believe, 1.02 practice. Appreciate you.